Okay, so the particle model, which we've already talked about in one of the videos, is really core to what we're doing. It's core to chemistry. So here's our particle model. Oops, not moving. There it comes. So you need to know how these particles create solids and gases, which we've talked about a bit in previous videos, and how the particle model distinguishes between them. So, as I said in the earlier video, matter is everything. So, table you're sitting at, computer you're using, your phone, food you eat, clothes you wear, air you breathe, it's all about matter. So everything we know is made of matter. And that matter is made of things called atoms. So you'll know of oxygen, it's an atom. It combines with other atoms to form other things like carbon dioxide, which you breathe out, or water, which you'll drink. So water's 2 hydrogens plus oxygen. Carbon dioxide is 1 carbon plus 2 oxygens. So they form these what we call compounds, which become more complex and gives us a variety of things we can use to make all this different matter. Atoms themselves are made of things called protons, neutrons, and electrons, and we call them subatomic because they're below the atom level. And there are all sorts of interesting little things that make up protons, neutrons, and electrons. So subatomic particles, getting smaller and smaller. We'll get to them later. So particle model, idea of the solid, liquid, gas. This idea that everything's made of these tiny particles. These things are constantly moving. More obvious in gas because they're further apart. They've had enough energy put into them to allow them to spread as much as they have. Still obvious reasonably in liquids because you know the liquids can move. But even in our solids, those particles are still in motion. They're just trapped within the shape they've been forced to take. And the more heat energy we add to this thing, so the more temperature, the faster they start moving. So the more heat I put in, I can move from being a solid to a liquid to a gas. Now, the atom. On the bottom here is a little diagram, a simple diagram of an atom. It has protons and neutrons in a thing we call a nucleus. And then it has these shells of electrons. So these little things are electrons. And they whiz around the outside here. This one has 3 electrons, which means I'll find 3 protons in there. And I know it's a thing called lithium. Lithium? Yeah. So, protons. We know these. We know we have 3 atomic particles. And we know 3 things about each of them. We know where to find them. Nucleus. Or in these shells. We know how much they weigh. So 1 atomic mass unit, which is a really small amount, or nil. Electrons have some mass, but it's so small it's insignificant. But then they also have charge. So protons have a positive charge, electrons have a negative charge, and neutrons are neutral. So this negative charge, positive charge difference means that these electrons are sort of attracted to the nucleus, but they're in orbit, they're spinning because they're trying to get away. So there's a sort of a attraction-repulsion thing going on. The neutrons are thought to actually add a bit of bulk and stability, otherwise this whole thing would fall apart. That's our theory of the atom, as best we understand it. So, elements are substances made of one type of atom. So this diagram here, all these little blobs look very similar. So we can think of them as being maybe the crystal structure of a diamond. And all these little blobs could be carbons, although they'd be cross-linked as well. And these are linkages between the blobs. So an element, one type of substance, nothing else. Oh, I'll see compounds. There you go. I'll keep compounds for another day.